So when we're doing conversions or dimensional analysis with area and volume, there is a really common misconception, which is to think that the relationship between these linear edges is the same thing for the relationships between their areas. And that is not the case. Like these two things are different ratios. So that's the most common misconception. But then it's like, how do I actually get these ratios? So if, like, for example, in 1 kilometer, that's 1,000 meters, right? And then that would be, what is that? 1, 2, 3, and then 100,000 centimeters, or 10 up to the 1, 2, 3, 4, 5 fifth power. Um, so there is not 10 up to the fifth power cubic centimeters in 1 cubic meter. The best way to imagine how this works is to just think about a cubic meter and then try and think about it in terms of cubic centimeters. So I know we're doing area right now, but it's very similar for volume. So we're going to think about some sort of cubic meter here. And so this is 1 cubic meter. Now the question is, well, these edges, how many centimeters do we have along them? Because I know my volume of something is going to be my edges cubed. So if each one of these is 1 meter long, that means that it is going to be 100 centimeters long. So you have 100 centimeters on each edge, and that can help you with this conversion factor. So you can say, like, okay, well, I've got 100 centimeters on each edge, and I need to put that up to like the third power to get this volume. And so this would be like 10 up to the second power times 10 up to that third power. So this is, what's that? 10 up to the sixth power cubic centimeters is equal to 1 meter. So we know that that is a different ratio. Like if you were to look at centimeters to meters, it is a 1 to 100 ratio, which is different than this 1 to, what is that, a million cubic centimeters. I mean, there's a lot of them in here. If you've got 100 by 100, that's quite a few. And then you've got 100 stacks of that. So that kind of makes sense that there's a whole lot of these things. So this is one of your options, is to look at the edges. Um, and then to use the volume or the area formula. That is one option. There is also a way to get the ratio and then convert directly. And we're going to show that off in this example problem. We'll do both option 1 and 2 to look at this calculation. So if I had 5 cubic centimeters, this is kind of hard to imagine this as an area, but it might look something like this, where we know that this is 5 cubic centimeters, and then this might be a square, and so each one of these edges should be square root 5 centimeters. And we can work with those edges and do some math with that. So we can convert those edges from centimeters into kilometers and then just plug it in. Because I know this times that would give me this area. I can do the same thing with kilometers. So if I know my ratio of centimeters to kilometers, then it's just kind of a matter of plugging it in here. This is square root 5, but the unit is centimeters. We want to cancel out with centimeters. I believe we're going to kilometers. And in every kilometer, there's 10 up to the fifth power centimeters. So this ends up, each one of these edges, if you were to say about that is, in now the kilometers, is going to be root 5 times 10 up to the -5 kilometers. So that's what each edge is. And so the area formula here, it's just those edges squared. So we just take that number and we square it. And when you do that, you should get 5 times 10 to, is that the -10? No? Yeah, I believe that that's how it works. Cubic centimeters for that area formula. So we could do that there. Now it might be like the square root 5 might be throwing you off a bit. So I'm going to just show a slightly different shape that has the same area. 5 cubic centimeters. Should have that cubed on there. So let's imagine that this is like 1 centimeter by 5 centimeters. So we can do the same math that we did here. But now we're starting with the 5 centimeters and the 1 centimeter. So you do have to think about this twice in a sense, but it's the same conversion. So I think you're probably seeing how this works. I'll just work through it just to make sure it's clear. So we've got 1 times 10 to that 5th kilometers, and we've got 5 times 10 to the 5th kilometers. And we know the area of something like this is length times width. So you've got that first number times that second number. And that does look like that is giving us the same value that we calculated just a second ago of 5 times 10 up to the actually, sorry, -5, -5, -5, -5. So this is a -10. Yeah, I was just thinking through the units there. I was like, that seems like you shouldn't have many cubic kilometers. Like it's a pretty small number, which should make sense given that we're talking about centimeters. Like kilometers are like huge in comparison. So that's one way to go through this. When you convert the edges directly and then use the formula. You can also get the ratio. So if we can say like the kilometer, like 1 cubic kilometer, if you're thinking about that, each one of these edges is 1 kilometer, and we're saying, well, how many centimeters is that? And that was the 10 up to the 5th number. So we've got like 100,000 centimeters on each edge, right? And so you've got the 10 up to the 5th number there for each edge. And actually, sorry, this is not a rectangle. This is a square at this point. So we're just talking about area. That makes it a bit easier. It's just going to be the 10 up to the 5th times the 10 up to the 5th to help you convert between kilometers and centimeters. So 1 km squared is now equal to 10 up to the 10th power cubic centimeters. So this is our ratio, and then you can just convert it directly. So we had the original number we had said was 5 squared centimeters. And then we're going to convert with squared centimeters to kilometers squared directly. So in one of these, that is equal to that number of those. So in one of these, there's 10 up to the 10 of these. And you can kind of see how this is working to give us that 5 times 10 to the -10 cubic kilometers, kind of like that. So to just kind of wrap this up, there's a couple options. You can either get the ratio between the two areas and then convert directly, or you can convert the edges first and use the formula. some of these make more sense for some problems and less sense for other problems. Something like this, if they've given you like 5 cubic centimeters, my gut wanted to do this and that made it a bit too hard to do. And so I think that doing this in the way of number 2 is more appropriate for my brain. But what I did here in blue works pretty nicely as a stand-in. I usually think about these things as like squares, but they can totally be rectangles. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there. And we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and our social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.